right, Trailblazers, here's your first real homework assignment for me. Hopefully you brought your composition book home like I asked. I do want you to go ahead and separate it in 2 sections. The first section is going to be for bell ringers, things we do in class. The second section is going to be for you to take notes in. So go ahead and, if you haven't grabbed it, go ahead and pause me and grab your composition book. You're also going to have a homework assignment at the end of this in which you're going to need graph paper for. You don't really need that right now, but you do want to go ahead and make sure that maybe you have an extra sheet of graph paper, or regular notebook paper, so that you know what your assignment is. At any part of this, if you need to pause the video because I'm going too fast, pause the video. By now you should really realize when you're taking notes for teachers that you shouldn't be writing every word down in the slide. You should just be writing down what I'm saying, what I'm emphasizing as important. We all take notes in a different way. You do what you think is best. Let's go ahead and get started. All right, so I know some of my stuff gets cut off. You can't really see the title, but it says, How do Scientists Explore the Natural World? And that's what science is. It's about learning about the natural world. Note that I said natural world. So even though we're all caught up in vampires and supernatural cool things, we have TV shows, maybe we read blogs, or we like anime, you know, that stuff is supernatural. Science can't really deal with it. So it's stuff that we can gain through exploration. So it's stuff that we're going to be using our 5 senses to observe, that we're going to classify data, we're going to make models, we're going to infer, we're going to predict, all that great stuff. So let's get started. First things first, observing. Observing means using one or more of your senses to gather information. So we know that we have sight, smell, touch, taste, and hearing. So a lot of times in science, it's going to be our eyeballs that help us out the most. But remember, there's 2 types of ways to gather information. There's quantitative and qualitative. This is going to be very important, so make sure you understand the difference between these 2, because this is where your homework's going to tie in. That's going to be due this Friday. So quantitative, the root word in there is quantity. It deals with numbers and amounts. For instance, Sally sprinted 50 meters in the track meet last night. 50 meters would be the quantitative data. If I relate it to a lab, I could say we started with 50 milliliters of hydrochloric acid, and we also added 60 milliliters of water. Those quantities, those milliliter amounts are where our quantitative data is. Qualitative data is a lot different. It deals with descriptions that we can't express in numbers. For instance, I can say the solution was bubbly and gave off a nasty odor of eggs. Here's the issue with qualitative data is we can't measure it. What maybe I call a solution purple, but you say, that's really light pink to me. So qualitative data sometimes can be rather subjective because we can't measure it. So just keep those things in mind. Again, qualitative deals with description. It can be observed but not measured because we all have different experiences we bring to the table. Maybe I say that's a really nice smell. Some of you love the smell of gasoline. So you would say gasoline, gas stations smell great to me. And others like me, I'm like, oh my goodness, that gives me a headache. Do you see what I mean with qualitative data? It can be very subjective based on who we are as people. Quantitative data, on the other hand, isn't subjective. It just is. It either is 60 centimeters or it isn't. Okay? So it deals with stuff that we can measure. So the roots are in the words. Quality, quanta goes to quantity. So let's look at these examples. If we look at the painting, the qualitative data we could get from the painting is that, okay, it's a pretty blue-green color, it's a gold frame, but see, this is where we can argue. You can be like, Miss Marshall, that ain't gold, that's yellow. Okay, maybe I think because it came from my attic, it smells old and musty. Maybe I say I can see the brush strokes of the oil paint. It makes me feel very peaceful. Maybe you're like, that doesn't make me feel peaceful. What's that black thing? Is that a bat? What's in that painting? So again, we can argue qualitative data. Quantitative data, not so much. The picture is 10 inches by 14 inches. With a frame, it's 14 inches by 18. It weighs 8.5 pounds. The surface area is 140 square inches. It costs $300. We can't argue that data. Another example would be a latte. So maybe I really love coffee, and I'm like, oh my gosh, robust means it's a strong, yummy aroma. It's frothy. It's got a nice, strong taste. That cup is burgundy. We can argue all those things. What we can't argue is the quantitative data. There's 12 ounces in that cup. The temperature is 150 degrees Fahrenheit. The height of the cup is 7 inches. It costs $4.95. Another example could be the freshman class. Let's use Bayside as an example. Maybe as a teacher, I'm one teacher, I'm like, oh my gosh, they're so friendly, these freshmen. They're civic-minded. They care about Palm Bay. They care about the community. They're environmentalists. My goodness, they recycle everything. They've got a really positive school spirit. But then maybe I go talk to Mrs. McCranky down the hall, and she's like, those kids are terrible. They're not nice. They're not civic-minded. They throw trash everywhere. What are you talking about? They recycle. They have a horrible school spirit. See where we can argue that? Quantitative data, no arguments. There's exactly 672 students, and I made this up, by the way. I don't know how many freshman students there are. I hope there are not 672. Maybe 394 are girls, 278 are boys, 68% are on the honor roll, and 105 of them are in a high-level math class. We can't argue that quantitative data. All right, this is not your homework. This is where you just try, go through it, and see if you can get it. Just take a minute. You can pause me if you need to. The answers, I believe, are on the next slide. Oh, nope, they're not. So number 1, hopefully you paused me. Number 1, right there, it's got numbers. That's quantitative data. Number 2, again, quantitative data. 3, warm outside is qualitative. The tree is 30 feet tall, quantitative. The building has 25 stories, quantitative. Now, number 6 is tricky. Number 6, a lot of times we want to say quantitative, but it's not. It's qualitative. It just depends on your perspective. Are you far away, and is the building closer? If you're far away and the building's closer, it might appear taller or smaller. We've all done this in the car where things look really tall or short when we're far away, and then we get up close to it and it's exact opposite. So that is qualitative data because it depends on your perspective. Same thing with number 7. And number 7, if I'm 3 years old, that sidewalk, man, my goodness, and my little itty-bitty 7-year-old legs are trying to keep up, that might seem really long. If I'm 6'1", that sidewalk might seem very short. So again, qualitative data. But the sidewalk being 100 miles long, that's definitely quantitative. The race was over quickly is qualitative. The race was over in 10 minutes, quantitative. All right. Now, I know you can't see my screen, chopped this off, but it says, you are at the beach and see some black and white birds and people. Which of the following are observations and which are inferences? So go ahead and pause me for a second. You can just, jot them down, see what you think. Go ahead and pause me now. All right, so I'm unpaused, hopefully, and let's go through it. It is summertime. Okay, that's an inference. We can't observe summertime. If people are at the beach and it's sunny out, we can infer that it's probably summertime, but we can't observe summertime directly, so that's an inference. It is daytime. That is definitely an observation. It's either daytime or nighttime. They saw birds. Remember when I prefaced this, I said you were at the beach and see some black and white birds. Seeing birds is an observation. Whereas number 4, they saw seagulls. That's an inference, unless you are an ornithologist and know for sure that those are seagulls. They went swimming. So all we saw when we were at the beach, we see some black and white birds and people. They went swimming. If we directly observe them swimming, then that's an observation. If we just see them hanging out on the beach, we can infer that they went swimming. So that one just really depends on what we actually see. One's friend's name was Bob. That just could be an inference. Unless you know for sure his name was Bob and you observed him saying, hi, I'm Bob. You heard him say that. That would be an inference. It was a warm day. If you're there, you're experiencing it, you're touching it, you're feeling it, that's an observation. The birds were black and white. Definitely. That is an observation. We observed their color. They are black and white. They ate lunch and drank soda. Now that again depends on, were we there? Did we directly see them eat lunch and drink soda? If not, we can infer that, hey, if they're at the beach during lunchtime, they probably ate lunch and drank soda. The people are friends. Maybe they're not. We don't know unless we hung out with them. So that again depends on where we are in that scenario. All right, so we have 2 types of scientific research. We have descriptive research. You're going to do, your homework assignment is based on both of these. I answer questions through observation. This is based on qualitative data. Again, can be very subjective. There can be bias. Bias is our own personal ideas that we bring into experiment. We would like to not have bias. Unfortunately, it's really, really hard to eliminate. So behavioral studies like how did you feel when this happened, that's descriptive research. Exploring Mars rock samples like saying that they're this color and they're this texture. That part of it would be qualitative data. Experimental research is a little bit different. That's where we have our normal standard scientific investigation with controlled variables. It's based on quantitative data. Remember, this is data that has numbers. It can be measured. For instance, a quantitative experimental research project might be if the color of paper influences test scores. Maybe I give tests on yellow, green, red, and white paper. Okay? I would give the same test maybe to the same people, and I would look at their test scores. I'm measuring something quantitatively.